Hi everyone. Today I'm going to help you solving some of the problems on 6.3 homework. So let's start with question number 1. You must order a new rope for the flagpole at your school. To find out the length of the rope that is needed, you must first determine the height of the flagpole. You observe that the pole casts a shadow which is 11.8 meters long. So this shadow is 11.8 when the angle of elevation is 37 degrees. So what is angle of elevation? So let's say there is a person standing here and he is looking at the sun over here. Angle of elevation is the angle which is made with the horizontal line to be able to look at something on top. So if this person is trying to look at the sun, he needs to raise his hand with angle of 37 degrees to be able to see the sun. So this is 37 degrees. How tall is the flagpole? So I'm looking for this side. I have a right triangle here, and I have the adjacent side, the angle, and I'm looking for the opposite side. Using opposite and adjacent side, I can make my tangent function. Tangent of 37, which is opposite over hypotenuse, opposite over adjacent is x, opposite side is x over the adjacent side, which is 11.8. Okay, now how do I solve this for x? Just set the denominator of 1 here and do cross multiple, and x times 1 is x. It's equal to 11.8 times tangent of 37. So I'm going to use this, leave this for you to use your calculator and find the answer. Now let's go to the next problem, number 3 here. The Rocky Mountain Turnpike has a steady uphill slope of 4.7. So let's say this is the Rocky Mountain Turnpike, and it has a steady uphill slope of 4.7. So this angle is 4.7. How long must a straight uphill segment of road be? That means how long must this side be? This is my x. In order to allow a vertical rise of 450, that means this side, this vertical line over here, should be 450 feet. And next is asking what is the horizontal distance, means this side, let's call that y. So first we'll find x, then we're going to find y. So if I consider a triangle here, a right triangle, this is the angle that I'm looking for. I'm starting my work with. So the side which is opposite this angle is this one, 450, and x is what I'm looking for, and that's my hypotenuse. So using opposite and hypotenuse, what function can I make? I can make my sine function here. Sine of 4.7, we know that is opposite over hypotenuse. So it will be, what is the opposite side? It's 450. And hypotenuse is x, that's what I'm looking for. So I made my equation. Now I'm going to solve for x. Again, denominator of 1, cross multiple, and from here, x times sine of 4.7 is equal to 450 times 1, which is just 450. Now, how do I solve this for x? Divide both sides by sine of 4.7. So these two cancel each other because I'm looking for x. I want to have the x by itself on one side. So I need to get rid of this sign, and it's multiplied by my x. So I divide it in order to undo that. So x is 450 divided by sine of 4.7. Now I'm going to use my calculator to find that. And here's what I already made for you. 450 divided by 4.7 is this number, 5491, 5491.92. So that's this side. Now, how do I find the other side? Y. I know that if I have this angle, the other side, which is right beside that, this is going to be the adjacent side. This one hypotenuse, this one adjacent. Now, using opposite and adjacent, what function can I make? I can make tangent. Tangent of 4.7 is equal to opposite over adjacent. Opposite side is 450 and adjacent is y. That's what we are looking for. Again, the same story. To solve it, just do cross multiple and then it will be y times tangent of 4.7 equal to 450 and y will be 450 divided by tangent of 4.7. And I'm going to leave finding the answer for you. Okay, now let's work on question number 5. An observer 5.2 kilometers from the launch pad at Cape Canaveral observed that the Discovery space shuttle take off. Notice that Discovery ascends vertically for some time after takeoff. That means it's going to go like vertically like this, just straight to the outside. This person is standing 5.2 kilometers away from that. Let's say this is 5.2. This is where the person is standing and is observing the Discovery shuttle. At some particular time, the angle of elevation is 32.3. What does that mean? That means if that person is standing here, he needs to raise his head by angle of 32.7 to see that Discovery shuttle here. So here's my triangle. The angle is 32.3. Once again, angle of elevation is the angle which is made with the horizontal line to look at something on top. Okay, now it's asking how high is the shuttle. Okay, this is what I'm looking for. This is my angle, adjacent side. Adjacent side is here, and this is opposite side. Now, opposite and adjacent is what I'm working on. Using these two, I can make my tangent function. 32.3 is equal to the opposite side, which is x, over the adjacent side, 5.2. And then we solve this for x. I'm going to leave that for you. Now it's asking how far is the Discovery from the observer. That means it's asking us to find this distance. Let's call that one y. This is what it's asking us to find. Okay, now this time I'm going to use the adjacent side and the hypotenuse. Adjacent and hypotenuse can make cosine functions. So I'm going to write cosine of 32.3 is equal to adjacent over hypotenuse. So it's 5.2 over y. Now from here, I'm going to set denominator 1, cross multiply, and so to solve for y. I'm going to leave that one also for you. Now the next question is asking, what will the angle of elevation be when the space shuttle reaches 28 kilometers? Okay, for this part, I'm going to draw a new shape just because this one over here is so messy now. Okay, now this distance is again 5.2 and this angle is 32.3. And now it's asking, what is this side? I'm sorry. I apologize. I made a mistake. The angle is not 32.3. The angle is what we are looking for. It's asking, what is the angle of elevation? So this is what we are looking for. And then says, when the space shuttle reaches 28 kilometers, that means this vertical distance is 28 here. 28. Now I'm looking for the angle. Okay, so again, looking at this angle, I have opposite side and the adjacent side. I can create my tangent function. So tangent of theta, let's call this angle theta, is what we are looking for, is equal to opposite over adjacent. So it's 28 over 5.2. So this is what I have. Tangent of an angle is equal to 28.52. Now, what is this angle? To find this angle, the angle is stuck in the tangent function. So I need to undo the tangent. How do I undo that? Using the inverse function. So I'm going to write theta is equal to tangent -1 of 28 over 5.2. Then I can use my calculator to find that. So I go second tangent of 28 divided by 5.2. 79.47. 79.47 is the angle. Now let's work on question number 7. Judy is waiting for the cable car to Powell, for the cable car on Powell Street in San Francisco. The street is extremely steep, and to pass the time, she decides to find out what angle the street makes with the horizontal. On the wall of a house, she measures a horizontal distance of 33 centimeters and a vertical distance of 5 centimeters along the slope of the street. Now, what angle does Powell Street make with the horizontal? So in order to solve this, I basically draw a horizontal line. And this is the street. The angle that I'm looking for is the angle that this line is making with the horizontal line. So I'm going to move this horizontal line over here because this is where she measured 33 centimeters and 5. So I'm going to move the horizontal line here. If I find this angle, that is going to be the angle that the street is making with the horizontal line. Why? Because like if I find this angle is equal to this angle over here, we have learned in geometry that if we have two lines crossing each other at one point, then the two opposite angles are equal to each other. So whatever is angle making here is made here, that's equal to the angle that is made here. That's also another rule that we have learned in geometry, that if you have two horizontal lines, two lines that are parallel, and another line is crossing those two from the other side, then this angle and this angle are equal to each other. So what is happening here? I'm looking for this angle. This angle is equal to this one, and this one is equal to this one. So if I find this angle, basically I have found what I was looking for. So to make it shorter, I'm just going to find this angle. I have a right triangle here, and I have the opposite side, which is 5, and the adjacent side over here, which is 33. How can I find the angle? Well, I'm going to use tangent function. Tangent of, let's call this theta. Tangent of theta is equal to opposite over adjacent, 5 over 33. Now, what is the theta? Just use the inverse function, tangent -1 of 5 over 33, and from there you can find the angle. Next, she is asking, while she waited, Judy walked up to the top of the block, counting 101 paces, approximately 101 meters. How many meters did she go vertically? Okay, so she is walking like up to this direction, and she's going like about the 101 meter. So let's say, for example, she goes from here to here, and this is 101. Now it's asking how many meters did she go vertically. That means what is this distance? This vertical distance is what we are looking for. We already found the angle, which was whatever is here. I already found that, and it was equal to 8.6. Now using this angle and this side, how do I find the other side? Again, I'm going to use trig functions. I have the opposite side and the hypotenuse. Why is this hypotenuse? Because I have a right angle here. So this is a triangle and the right angle is here. This one will be the hypotenuse. So opposite and hypotenuse make sine function. So sine of 8.6 is equal to opposite, which is x, over hypotenuse, which is 101. And from there, use the cos multiple and find x, which is 101 times sine of 8.6. Okay, now let's work on question number 8. A rocket shoots straight up from a launch pad. So let's say it's here and shoots straight up from a launch pad. So it goes vertically. We know that the rocket goes vertically. Okay. 5 seconds after liftoff, Billy, who is standing 2 miles away, so let's say he's standing here 2 miles away, notes that the rocket's angle of elevation is 4.6. That means if he's standing here, he is making an angle of 4.6 with the horizontal line to see the rocket. So let's say it's here at like about, what was it? Yes, about 5 seconds after liftoff, he looks at the rocket, and the angle of elevation at that time is 4.6. Okay. Next, 4 seconds after that, again, he looks at the rocket. Then 4 seconds after that, the rocket is still going up. So now it's, let's say, for example, at this point. This time, he's trying to look at the rocket, and now he needs to make an angle of 38 degrees to see the rocket. So this time the angle of elevation is 38 degrees. Now it's asking how far did the rocket rise during those 4 seconds. So basically we are looking for this distance. So here the first thing that I'm going to do is to look at the triangle that I have at this point. One of the triangles that I have is this one. Let me draw that here again. So in this triangle, I have this side as 2, this angle, which is 4.6. So using this triangle, I'm going to find this side. This side is opposite of this angle, and the other one is the adjacent. So I can make my tangent function. Tangent of 4.6 is equal to opposite side, which is x, over the adjacent, which is 2. So from here, x will be equal to 2 times tangent of 4.6. Tangent of 4.6. So I'm going to use my calculator to find that. 2 times tangent of 4.6. It will be 0.16. I'm going to write that 0.16. So this means I found this part of this line, which is 0.16. In order to find the other part, y, I'm going to find this whole line and then subtract 0.16 from that. Then I will be able to find y. Why am I doing that? Because using this triangle, this big one, the green one that you see here, I'm able to use the trig function and find the other side. Using this little one over here, I'm not able to find anything because that's not a right triangle. this one, this big one, is a right triangle, so I can use trig functions for that. Okay, so I'm going to use this big one. Let me draw that here. Okay, so this angle is 38 degrees. This is the big one, 38 degrees. And this side is still 2. Again, I'm going to use the same thing that I did here to find the opposite side. So tangent of 38 is, let's call this one z, this side as z over 2, and z will be 2 times tangent of 38. Okay, so what is 2 times tangent of 38? It's equal to 1.56. 1.56. So I found this whole line, 1.56. Now, in order to find this little one, this y here, I'm going to subtract them. So y will be z minus x, which is 1.56 minus 0.16, and it's equal to 1.4. And this is my answer. I will leave the rest of the problems for you to solve. You can ask me if you need any help. Have a great day.